All right, so today we're going to look at volume. We've been looking at area, surface area, and so volume kind of goes along with those 3D figures. So area, when we talk about just area, that's how much space, like something two-dimensional, something flat, how much space it takes up. So if you're looking at a floor or the top of a table, something like that, how much space it takes up. Surface area is taking a three-dimensional figure, so a box or something like that, and saying how much total surface space is there on that box. So if I took every side, found the area of every side, or laid the whole thing out flat, unfolded it and laid it out, how much space would it take? Volume is how much it holds. So you can kind of think about like a pool. The volume of a pool would be how much water it can hold, or the volume of a bucket or something like that. How much can you put into it? But we talk about volume in cubic units. So think about taking a bunch of little cubes, little Lego pieces. And how many of those little cubic Lego pieces could I fit into this box if these are the dimensions of it? So that's kind of what I'm looking at. So there's going to be two things about volume that I'm going to show you. One is if it's just a rectangular prism. So this right here. If it is just a rectangular prism, it's actually pretty cut and dry. Rectangular prisms are, you take the length times the width times the height. That's it. Okay, length times width times height. So if I'm looking at the one that we have here, okay, I've got a length of 8, a width of 2/3, and a height of 5. And so that's what I'm going to multiply. I'm going to multiply 8 times 2/3 times 5. And you can use a calculator as well, but if I was not using a calculator, 8 times 2 is 16, and 16 times 5 is 80. 1 times 3 times 1 is 3. And so 80 over 3 is the same thing as saying 80 divided by 3, which comes up to 26.6 repeating. And volume is always units cubed. Now, if you'll notice, this says round to the nearest hundredth. So actually, I would call this 26.67 when I rounded it. Units to the third power, units cubed. But notice what I did. It was a rectangular prism. How do I know it's a rectangular prism? Because the sides are rectangular, and then also the end piece is a rectangle. Because a prism has rectangular around it, and then you name it by the end piece. So this one's a rectangular prism because of that. Length times width times height. That's it. Length times width times height. And main thing is just paying attention to maybe how you have to round it or something like that more than anything. So all right, let me get that off here so that we can look at the next problem. But I want to show you something else because there's another type of volume problem here in a second that I've noticed that when people take the focus area, they have the most problem with. And so I want to make sure that everybody's good with it. Even if you've taken the focus area already, I want to make sure that you're good with it. All right. So can I bring those out here? All right. All right. So I had a little problem with the tools there. I had to pause for a second. But now looking at the next one, so same thing. If I'm looking at my formula, it's a rectangular prism, length times width times height. Okay. So here we go. I'm going to take and multiply all of these. I'm going to do 12 times 1/4 times 4/5. Now, let's say, for instance, you have a calculator that doesn't do fractions. Well, if I do 1 divided by 4, I can find out this is actually 0.25. And if I do 4 divided by 5, I can find out that this is actually 0.8. So I could actually just multiply by the decimals. So I'm going to do 12 times 0.25 times 0.8. and I get 114, and that would be units cubed. Length times width times height. Length times width times height. That's what we're looking at here. Now, let's look at, though, a different issue that you'll see in the next set of questions.